Hello everyone, hello sir. My name is Samruddhi Bhosale and today I am going to present my ISC activity on the topic Service Oriented Architecture and Logical Clocks. My roll number is 43. In this presentation we will understand the introduction to distributed cloud computing, why the service oriented architecture is used, what the logical clocks are, and how Lamport logical clock helps us to maintain the order of the events in distributed system. So let's begin. Introduction to distributed cloud computing. Before understanding the SOA and logical clocks, first let's understand what the distributed system is. A distributed system is a collection of multiple computers or servers or processors connected through a network which works together to achieve a common goal. For example, when we use Google Search, Gmail, or Amazon, the work is not handled by a single computer, but the user feels it is like a centralized system. Instead of many servers located at different places works together and provide the services to the users. Now, when the distributed sources are deployed onto the cloud infrastructure, it is called as a distributed cloud computing. One important thing here is the computers are independent and they communicate each other through messages and they coordinate their activities. In simple words, the distributed cloud computing allows multiple computers to work together like a team to provide the reliable and scalable services. So, each service platform only one specific tasks and communicates with other services whenever needed. So this makes system easier to develop, manage and maintain. So basically SOA follows the idea of dividing a large problem into smaller manageable services. Now let's understand the main components of SOA. There are three main components of SOA. The first component is service provider. The service provider creates and provides a service. Then the second component is service consumer. The consumer is the user who wants to use the service. And the third component is service registry. The service registry acts like a directory where it maintains the record of registered services. And the process is very simple. First, consumer finds for the service in the service registry, and finally consumer binds to the service and starts using it. So the process is called like publish, find and bind. Then the examples of service providers are authentication services, product services, payment service, order services, etc. But however, the SOA has also some limitations. Since services communicate over network, there can be the network delays, which is called as a network latency. There may be the security challenges because security becomes more challenging because multiple services exchanges the data. Also, the deployment and maintenance require the additional efforts. So overall, SOA provides many benefits, but the proper management is necessary. Then move toward the second important part of the today's topic, which is the logical clocks. In distributed system, there are multiple processes which are running on a different computers. Each computer has its own physical clock, but the problem with physical clock is that they are not always perfectly synchronized. Also, the network messages may take the different amount of time for the traveling. Because of that, it is difficult to determine the exact order of the events occurred. For example, there are two servers which are performing action at almost the same time, but we may not now know which event actually happened first. So to solve this problem, we use the logical clocks. It is not, we have to remember that it is not like a physical clock, but it is one of the counter which is embedded with the processes, which increases when it sends the message, receives the message or any event happened. Let us understand the concept of Lamport logical clock by an example. There are three processes called as P1, P2 and P3. P1 sends the message to P2 and P2 sends the message to P3. Here from arrow we can recognize this is a sender and this is a receiver. But the thing here is, here we can observe the P1 is receiver, timestamp of P1 is less than timestamp of P2. Timestamp of P2 is less than timestamp of P3. But here the timestamp of receiver itself is greater than timestamp of sender is greater than timestamp of receiver. So to adjust this, Lamport logical clock adjusts its clock time by +1 to the sender's timestamp. Now the Lamport clock algorithm. Let us understand this by using three important rules. Rule number 1 is for internal events. Whenever a process performs a local event, it increases its clock by 1. So rule number 1 says that clock is equals to clock plus 1. Then rule number 2, that is send event. Whenever the sender sends the message, the clock will be incremented by 1. And rule number 3 is for receive event, where C is equal to max of C comma T plus 1. So C is the receiver's current logical clock and T is the timestamp of received with that message. So to conclude today's presentation, the SOA helps us to build a large distributed application using independent and reusable services, and logical clocks helps us to maintain the ordering of the events when the physical clock cannot be perfectly synchronized. And the Lamport logical clocks also provides a simple and effective method for assigning the timestamp of the distributed system. And the SOA organizes the distributed system, while the logical clocks organizes the logical order of distributed events. Thank you for watching my video. Have a nice day.